Welcome to the Futureering podcast. My name is Philip Sarek. My goal with this podcast is to highlight some of the incredible science, technology, and innovation happening in Australia, and some of the key individuals who are helping to build the future. If you are interested in supporting the Futureering podcast, or simply want to keep up to date with the latest episodes being released, then I highly recommend you subscribe to the Futureering Substack channel. The link to this will be in the podcast description. I'm also excited to announce that we have launched the Futureering community on Discord. Now, this is a free community for anyone in Australia that's interested in science, technology, innovation, and learning how to build the future. This is where me and others will be hanging out, spreading ideas, talking science, talking technology, talking how to build really valuable products that impact the future of humanity. Then this is the place for you. Whether you're someone who's studying at university, whether you're a scientist or a researcher, an engineer, innovator, or entrepreneur, then this is the community for you. Now, on with the episode. On today's episode of Futureering, I am joined by Joni Sytsma. Joni is an aerospace engineer and is currently the CTO of iLaunch at the University of Southern Queensland and the founder of Outerloop Engineering. Now, Joni is an incredible engineer with such a wide breadth of experiences across the aerospace and defense domains, spanning everything from working on drones to rockets to guided weapon systems. Now, if you're interested in any of these things and want to learn more about R&D and deep tech and engineering and innovation in any of these sectors, I highly recommend you listen to this incredible episode with Joni. Joni, thank you so much for coming on the podcast.
Oh, pleasure to be here.
Yeah, so we've known each other for quite some time, and I know a bit about sort of your background and experience in your journey so far, but I'd like to give our listeners a bit of a background as to you and your story. I know you have a whole breadth and depth of experience and skills and, just life experience. So, can you give us a bit of background about, where you are during, like, what you've gone through during your career and everything you've done so far?
Oh, so you want the Joni pitch? Wow. So I've had a really interesting career. I started my high-tech adventures at University of Florida. Started going to school there in year 2000. I was only ever going to study aerospace engineering because I have always been passionate about space and rockets and satellites and airplanes. And all I really wanted to do when I grew up was to build cool things that fly. Got finished with the undergraduate degree, and basically the space shuttle had just blown up in 2003, and the war in Afghanistan had just started. And that meant the aerospace industry, which is, it runs on different cycles than the rest of the economy. So I popped out and saw that I couldn't get a job, and none of my friends got jobs. It was really weird. So, when you can't get a job, go do some more school. So I got a assistantship working on the things we call drones. Although back then we didn't call them drones, they were micro vehicles. And I was working at University of Florida's MAV lab. And we built, at the time, the smallest, most capable drones in the world. These things were smaller than your hand. They could fly 15 minutes. We put little tiny cameras in them. We flew them kilometers away, and we participated in the International Micro Vehicle Competition. And
Nice.
Basically, the university team won it every single time, first place for 9 years in a row. We were that good. What that taught me is rapid innovation. Is like, we built the drone. No, we woke up in the morning with an idea. We designed it. We fabricated it. We built it. We flew it. We crashed it. And it took no time with these fast learning cycles to finally get things that flew and flew well and flew better than everybody else in the world. That was an amazing experience. And I was running a wind tunnel in addition to designing and fabricating and flying all these little drones. And ultimately, I popped out of my master's degree and got picked up by the U.S. Air Force doing weapons integration onto fighter jets, so F-15s, F-16s, A-10s. I learned really well professional C++ software development because we were developing tools to help us in our day job. Um,
Yeah.
and the fun part is we got to fly. We got to fly lots. Like I'd probably do a flight test a month. And the flight tests were pretty cool because, I was in the loads group, and our entire goal was to put the weapon and the airframe through its paces. So we would
Mm.
push those aircraft to the limits, maximum Gs, maximum speed, shake and bake down in transonic when the pilot's talking over the radio and yeah, it was pretty exciting, and not to mention, got to get my hands on a lot of really cool, really real military hardware. Um, I lasted about 2.5 years in that job, but then the laboratory came calling and what they could do because I knew the laboratory, the Air Force Research Laboratory Munitions Directorate. They were the ones who was making all the cool things that we were testing at Seek Eagle. And I got an interview over there, and I got to say, that was the easiest job I ever got because I walk into the office and they have this glass case filled with all the drones that I fabricated and built during
Oh.
my master's degree. And they're playing this video on the wall of this cute little drone I built that had legs that walked, and we walked it off of a building, and then it caught flight, and then it was before we had quad rotors, it was fixed wing, so it had to like take flight.
Yeah.
And so in the interview, I'm like, well, I built that. I shot that video. I designed that aircraft. And so I was in, and then immediately, my first assignments was teaching the, the organization how to build drones the way we did in the university. So setting up a composites fabrication facility, setting up the electronics laboratory, um, teaching people how to design the drones the way they needed to be, and then integrating all the components. And then the last part is, of course, flight test. And this was all like playing with toys for a bit, but then we started working on a project that was basically the predecessor to the Switchblade drone. So it's a pop out of a tube thing, the wings fold out, the motor turns on, and then the autopilot takes over. So many years ago, we designed the wings, got the wing folding mechanism working, and worked through the literally million issues in the autopilot and getting that autopilot. Because back then, we're talking quite a long time ago, 2008 or so, the autopilot was absolute rubbish. Um, so in those days, it was a bit more of the same, rapid innovation. We'd put the drones together meant to crash, because most of the times we'd catapult them off and they just go squish. And then
Yeah.
the first one we'd spend a month building, and then it broke first flight, and then we learned how to build them faster. We learned how to design them. If you ever had one of those Nokia phones, but maybe you're too young for that, one of those dumb Nokia phones where when it
Yeah.
hit
Yeah.
the ground, it exploded into 100 pieces, and then you would
Hmm.
just click it back together. So, we took some learnings from modern industrial design and kind of put that into it so that we could fly, fail, learn, put it back together, and most of the time we would put it back together, fly again in the same day. Um, we got that system to the point where it was capable, and we demonstrated it. We led through to live fire trials, and ultimately it spun out into a program office. So at that point, it left my hands, and turned into what everybody knows as Switchblade today. So that was a really cool program of transitioning my master's degree learnings into an actual system that's fielded in the market. Um, About that time, the Air Force refocused away from drones and small vehicles in general. And I moved over to the hypersonic weapons development program, which was spinning up in a big way. And I was the technical lead for the weapon airframe structures group. And so that meant we had to understand how to design these things from a fundamental perspective all the way down to nuts and bolts. And then after designing them, we had to learn how to control them. Because hypersonics, there's a lot of critical characteristics behind their control. Um,
Mm-hmm.
so I led a team. It was my first time leading a team. Before that, I was either participant in a team or an individual contributor. And I gotta say, I made a bunch of mistakes. But having my first team leadership activities over a decade ago, learning those mistakes back then has really served me well now because whereas I think whatever I did back then wasn't quite agile, wasn't quite efficient, I certainly made plenty of mistakes, but I only learned from mistakes. And I think I've learned a lot how to lead teams and how to manage major technically difficult projects, and ultimately be a better program manager. So, concurrent to the hypersonics program and kind of coming on after, there was a next generation air to air missile program. And that had very different requirements. So, basically, it was a more traditional kind of system as opposed to the hypersonic systems, which were quite new.
Mm-hmm.
But high agility. So whereas the other hypersonic system, it was all about the materials and the structures and how you put the thing together and how you control it for its characteristics. The air-to-air was really guidance navigation control, is learning how to steer the thing really, really well. So in that experience, I learned quite a bit about steering pointy things aggressively, and I thought that was a pretty cool program. Now, in these experiences, like I gotta say, those are really expensive systems, and I
Mm-hmm.
never got to touch any real hardware. So I went from early career where I'm actually playing with airplanes, real airplanes, and then I spent some time working with toy airplanes, and then now I'm designing these things, but I never got to touch them, and we never cut metal. And I told my boss, over in Australia, they're launching hypersonic rockets just about one a year. And I bet if you send me over there, I'm going to learn a ton. I'm going to really understand the technical difficulties of fielding these things and operating these things. And I'm going to come back and I'm going to be the best program manager ever of the next thing we need to build. Um, all but one of those things I think are true. So, as it turns out, they seconded me over here to work with DST on the HiFire program. And prior to my arrival, HiFire had a long history of success and failure, as you do in the rocket business.
Yeah.
It started as the High Shot program, which was run out of UQ. And basically, on its success, DST said, well, we want that inside our house.
Mm-hmm.
It was an unclassified program. It was largely scientific in nature. It was basically if you need to learn how to do these things, the only way to learn is by doing it every year, and trying to up the cadence so that you can speed up those R&D learning cycles. It utilized large sounding rockets, primarily the VSB-30, which is a two-stage, very large sounding rocket, to propel payloads up to really high altitudes, hypersonic speeds. And what I came into is a project where we were preparing HiFire 4 for launch. So this was vehicle integration. And if anybody wants to know what vehicle integration is, that's take it apart, put it back together, take it apart, put it back together 100 times because when you're in a production zone, somebody's already done all the instructions. this is us developing the instructions of how to put it together and then putting it together wrong or breaking something and then having to take it apart, fix it, put it back together. A lot of qualification testing. So stick it in a vacuum, thermally cycle it, put it on a shock and vibe table and shake the crap out of it and hope you don't hear something go tink, tink, tink. And then you hear something go tink, tink, tink because you broke something. Then you have to take the whole damn thing apart, find out what broke, fix it, put it back together. So a lot of that all the way out to Woomera to launch it. And that was big fun. And I got to go on one of the best field trips of my life where we went on a convoy way out into Woomera, like 500 kilometers from the launcher, and find the downed rocket because they have a clean range policy and they're not cool to leave them out there. And that
Yeah.
was like a real outback adventure. Um, Following on to that, I think I did a good job at work, and they put me in charge of HiFire 7B. I was the scientific lead. That meant that it was my science experiment. So concurrently with doing my mechanical tasks, I was building up a simulation framework to assess some things according to my other specialties. And my science experiment, but it was my program to manage. It was roughly a 1 year program, but from program initiation to launch was 10 months, so an extremely rapid program. We started with a rough design, but we really had to get a bunch of stuff manufactured, get a bunch of PCBs populated and put together, get all the computers working, modify the software from the previous flights, wire it up, and then go through full qualification. Meanwhile, I was program managing multiple activities. So there was
Yeah.
the efforts inside the house, but then I had to deal with the supplier of the rocket, who is DLR, the German aerospace company, but also had to deal with the supplier. They buy them from Brazil. Defense logistics, so get a C-130 to fly to Brazil, pick the rocket up, and fly it to Woomera. Deal with range safety and convince range safety that the range safety footprint was acceptable. And deal with the range because they're different people and different activities. And
Yeah.
so ultimately, having to herd lots of cats all the way to success. So in that project, I learned a lot. We estimated it was probably like a $20 million project, so pretty substantial. I'm real proud of my time. That's actually my huge career highlight. And if I could launch more rockets like that again, I mean, sign me up, man. Like I'm in. Um, I didn't really want to go back to my old job. I was in love with Australia, and at that exact moment, Gilmour Aerospace had done their first big raise, and they were about to scale up the company and go for gold. And I was really excited. You know, I had rockets on the brain, and I was managed to get a visa with them and stay. And that allowed me to start working for them on their One Vision sounding rocket. It was a kind of a not super high performance sounding rocket. It was uh, relatively low altitude, but it was a demonstrator of their hybrid technology. And I mostly led the range safety activity behind that. And that was about like a year and a half worth of effort out until when we tested it. And unfortunately, that rocket exploded on the launch pad. So,
Oh, damn.
one thing, yeah, well, look, the thing about rockets is like it's going to succeed or fail in like 5 seconds. So, you know,
Yeah.
well, particularly developmental things, if they haven't been designed and they didn't have a pedigree of success, then it's hard to expect success right away, right? Um, but about that time, Gilmour was expanding their sights on their orbital launch vehicle, and I transitioned over to be head of guidance, navigation, and control. Um, I had a few skills under my belt, you could say, but I do have a passion for steering aerospace vehicles with software and computer systems, cyber physical systems, really. And I started with 0 lines of code at in that effort, and we worked through and built a quite capable system until essentially I had to leave. Due to COVID and ITAR and other complications, I ended up leaving Gilmour after being there just less than 2 years. It was a shame. I would have liked to stay with them to see their rocket fly into the sky. And I look at the pictures of it laying on its side, and I'm just a little bit bummed I don't get to help them launch it because I think, rockets are cool.
Yeah,
After that,
absolutely.
I started Outer Loop Engineering with the intent of trying to build an aerospace business. And I'm still trying to run Outer Loop Engineering, but at that point, I think I was a bit too immature. You know, Technically competent, not very good at business at all. 6 months passed, made no money, starting to go hungry, and starting to get pretty stressed out. And of course, we're in the middle of COVID, which is a very stressful time anyway. So I took a job at Emicent, and Emicent builds these really cool lidar mapping drones. And I worked there as a technical program manager, but I quickly got picked up by Department 13. Department 13 hired me as the chief technology officer, and I took it on as like a super big challenge because I wanted to. This is a company that was a startup that just about failed and got saved at the last minute, recapitalized by investors in Canberra. And it was an American company, and my job as the new technical lead was to move the entire company's hardware, software, and IP, and yet move none of the people because remember, it's COVID. And so hugely challenging to get all of the learnings and understanding of the product out of the company. I was supporting a company a product that I had never seen, and I didn't actually see that product until about 4 months working there. So that was kind of crazy, but I figured it out. While I was there, I designed their entire new product line, and there's a product that I designed that's on the market right now. It's called Scout. It incorporates a radio direction finder that I designed from first principles, which was pretty exciting. And the story behind that's not great. I'm locked down in my apartment, not allowed to leave. I'm having to lead my entire team 100% remotely. My internet at home was awful because everybody's doing Zoom nonstop. So I had to do all my
Mhm.
business through my phone, and I had to lead my team of, about 15 people at that point to develop all the hardware, all the software, all the engineering understanding and algorithms and stuff to build the prototypes. And a week after lockdown was lifted, we demonstrated it on top of Mount Stromlo, and it had amazing performance. It worked perfectly. And I was like, very stoked that here's something that under extreme adversity we'd managed to research and development into a TRL 4 or 5 prototype. Um, and then over the next couple months, we matured it into a product that's, out there selling on the market now. So, you know, I've got a bit of the entrepreneurial bug. And if you remember, middle of 2022, there was so much froth in the market. We just came out of COVID, so everything was looking super positive. Um, the interest rates were near zero, and venture capital was flowing into all sorts of crazy projects. I wanted a
Yeah.
piece of it. I wanted to build something really cool. I wanted to build a business in Australia to make Australians proud and to, not just be miners. Like we can build space hardware. Um, but that was the wrong time to quit my job and chase my dream because immediately after I resigned from Department 13 to chase the startup hustle. Uh,
Hmm.
Bitcoin crashed, interest rates started rising, venture capital dried up. And add on to that is I'm inexperienced and don't know what I'm doing in business. And yeah, that didn't end well. But look, you got to try to learn. I learn by doing, and if I can learn fast, speed up those research and development cycles, that's how you get results. Um, so anyway, I did that for like 6 months, and I think I was starting to, get some market traction. And then I was offered, I don't know, something that I feel is super cool. So Australia, up until basically the beginning of this calendar year, hadn't really like invested in space nationally. The creation of the Australian Space Agency was much lauded, but like it's the money that makes things happen. And I was interviewing for what is, at least at present, Australia's largest space grants program, and it's called iLaunch. iLaunch is one of the six university trailblazer programs, and it's $180 million research and development, manufacturing and commercialization program over the next 4 years. And I got picked to be CTO. So I started work in January at the University of Southern Queensland, and I've been doing my best to execute against the program ever since. Gotta say, I thought I was a good program manager. This is testing me. At present, I have 18 projects in my program, about $45 million budget a year, give or take. Um, uh, with each project, there's, between 3 and 5 people, so that is quite a large quantity of hats to herd. A lot of reporting, a lot of KPIs that need to be met. Um, I gotta say, I'm working with a killer A team. Like they're really, really good, and I really like working with Darren and Melissa. They're absolutely fantastic. So, anyway, that's a little bit about my background that brought me here today.
Yeah, first of all, that's just, yeah, pretty incredible. I mean, just the amount of different experiences you've had from, drones to rockets to weapons and coming over to Australia to work on HiFire and work at a bunch of interesting companies. Yeah, it's incredible. And you seem like a very, I guess, multidisciplinary engineer in that, you're doing heavy R&D and innovation and prototyping and systems integration and mechanical design and control systems and a whole bunch of stuff. So
Well,
that's really cool to see. There's not many people
software,
that,
and then,
yeah,
yeah, well,
just keeps going on and
maybe
on.
I'm not so good at all of them.
No, that's incredible. So yeah, at the moment you're currently CTO of USQ iLaunch, which is a very interesting program, as you said. Yeah, it's pretty cool to see how Australia is really investing in space and defence right now. It seems to be a big push for that, which is really cool. So these programs that you're discussing and you're sort of trying to manage at the moment, are they internal programs or are they startups which you guys are funding?
So iLaunch is a consortium of 3 universities, and it's an industry-led program. Fundamentally, we have startups, we have primes, we have anywhere in between. And basically, these folks out in industry say, we're working on a project, a product, a technology, something related to space, hypersonics, advanced materials, additive manufacturing, communications. And like, the secret sauce is missing. Like, it needs to be cooked, and we need your help. So what the universities do and the researchers in the university, they're the people who are working on developing critical components that are fundamentally necessary to develop these advanced aerospace products.
Yeah, okay. So it sounds like then it's more, yeah, your bigger industry players coming in to help, solve specific problems or build specific products as opposed to, startups going, hey, I need a product. Can you guys help me develop something?
As it's a matching grant program, you have to bring some money to the table. So,
Okay, yeah.
I really wish we could offer some sort of assistance to the smallest of the early stage, but the realistic part about iLaunch is it's a short program. It's 4 years long, so you don't have a lot of time to develop a product from nothing, from an idea to flying into space, because space is hard, right? So
Absolutely.
ideally, we ingest products and projects from TRL 4 and 5, and then we kick them out, ideally at TRL 7 or above. So it's a narrower research and development activity. I'd say it's small R and then big development. So more engineering, although for sure there's some research in there. And it's very manufacturing focused. The things that we're working on in iLaunch are real, right? This isn't software. This isn't pure software. Um, we are working on software. You can't escape software in 2023, but in the cases where we are, the software makes the hardware do the magic that it does. So anyway, it's a really cool program, and being manufacturing, there's going to be a lot of visuals. You're going to see satellites, you're going to see satellite subcomponents, you're going to be solid rocket motors flying into space. So real things are being built, manufactured right here in Australia, and that's really what iLaunch is all about. It's about pushing the dial forward on aerospace manufacturing.
Yeah, no, that's amazing. We definitely do need to bring back manufacturing and I guess heavy R&D, especially in industry in Australia. I think that's what's lacking, and people going out and they're actually building products which are going to, provide value to the country. That's amazing. So you're also operating Outerloop still, as well as working full time with iLaunch. So give us a bit of a breakdown as to what you're doing exactly with Outerloop right now.
So look, I'm really passionate about machine control, and I'm talking about robots, right? But specifically, as we talk about cyber physical systems, I like to control flying things, and I think I've got a lot of experience in controlling flying things. So what I see in Australia, and in particular in iLaunch, because I work with these folks daily, um, is there's a lot of rocket development, but not a lot of steering the developed rockets. So what's going to be occurring over the next several years in Australia is you're going to see a proliferation of multiple companies developing solid and liquid rocket motors and advanced propulsions. I'm talking about scramjets and other advanced propulsions, advanced electric propulsion. So there's a lot of propulsion work. And what I see is a big lack in the ecosystem is the folks who develop these propulsion systems, if they want to really value add them and demonstrate them in a real environment, they got to be able to control them. I can tell you from experience that developing control systems, aerospace control systems that are trusted, verified, and validated, let's just start with a number and say $5 million is what you need to get to achieve control of a rocket, and that's just a start. If you want to do really amazing things, then you might need to have a budget like I had several years ago, and you might start talking about 10 million plus. So what that means from a startup perspective is they have to raise the money necessary to make their propulsion system work. Step one, and that's not easy. And then they got to raise, just say $5 million more to steer the thing.
Yeah.
And I think that if I am developing outer loop, and I called it outer loop because it's the outer loop of the control system, so it's a control geek joke.
Yeah.
But developing a startup that is focused around controlling other people's propulsion system, and then I would like to be able to, in an agnostic way, strap on my control onto their system, help them prove that they work, build my system up because if I don't go from $0 to $5 million worth of capability overnight. So
Mm.
I'm doing this slowly, or as fast as I can, I guess. Um, Self-funded for now. I'd like to do quite a few test flights before I would think about any sort of rapid expansion. Um, but ultimately, when you think about the value in developing these sort of technologies, it's definitely there. To fly one major sounding rocket like a VSB-30 with a guidance navigation control tail kit, that's $1 million add-on, you know? And I'm just saying that if I could build that for Australia, I could do something similar to what DLR does for Europe. Um, and DLR is a government organization. I'd like to find some government funding eventually, but it's okay. I'll get there eventually.
Yeah, yeah, yeah. No, I like that. I think you are addressing definitely a gap and a need. Instead of building an entire system, you're providing a very critical component, which then you can sell and integrate with other companies who are building, propulsion systems, rockets, guided weapons. Yeah, there's a lot of good applications, I think.
As much as I love manufacturing and aerospace hardware, I think of Outerloop as a software company, fundamentally. It's going to enable the hardware to do what it does, but selling a software company, I feel, is more palatable in 2023. Everybody knows what a SaaS offering is, and most of the froth that happens in Silicon Valley is a SaaS company pops up to solve that, problem for some market segment. I mean, that's what this is. This is a software company to solve a market segment that basically is valuable and underserved. The folks who do have this capability are prime contractors, and they can't be bothered, quite honestly, to help these startups with their small projects. On the other hand, I just want to launch some rockets and fly some stuff, and I look at what I want to do in my future, at least for the near term. If I can steer somebody else's rocket, this puts me right in the middle of it, and that makes me smile.
Yeah, no, definitely, definitely. You get to, yeah, sort of put your product in a lot of places and, yeah, get that exposure and continue building from there, I guess. That's just the first step. I love that. So, do you have any advice for others who are wanting to build, say, a product or a startup in either defense or aerospace? So, what gaps are there in the markets? Like, what should people be doing right now and focusing on?
So I'm not going to talk about the gap, but I'll talk about how hard it is to build a hardware startup versus a software startup. Because, look, if you find the gap and you demonstrate it, um, the next thing is getting the money. Because without money, hardware startups are really, really hard. You know, Software startups can be built with a couple of people sitting in front of their laptops in their garage or in their, nice work from home desk.
Yeah.
So fundamentally, the barrier to entry is very, very low. And raising the financing to just hire bums on seats is pretty low. Um, Hardware startups, and in particular aerospace hardware startups, uh, they spend a lot of money because the hardware is expensive. When you put the hardware together wrong, it's very expensive to put it together again. And then there's almost no such thing as a pure hardware, right? Because as I was saying, you could be a unique propulsion system, but the real value add for your product is the propulsion system, the autonomy system, and all the production to put it together. So, like, it's challenging, and the financing landscape in Australia, I'd say, is more challenging than America. It's really easy to make money on real estate here, and so that means investors are like thinking to themselves, why should I invest in a hardware startup that might not make any money and might take a lot of money for a long time when I could just dump money into real estate? Uh, and make at least a solid return. And they're not wrong. So in Australia, I think it's very challenging to get a hardware startup funded. And then we're a small country. I'd like to say I'd like to see the government do more, but they can only do so much. Our tax base is 25 million people, so nowhere near the economies of scale of America, Europe, Asia. So what you've got to realize is if you want to build these kind of products, you got to have some sort of competitive edge. And I think that's why my approach is to work the day job and to consistently burn the midnight oil and try and get something off the ground, demonstrated and flying. And Australians are kind of used to the no money being far from everywhere. So, like, you just got to be scrappy and figure out how to do things the least complicated way and the least expensive way. Um, on the other hand, coming from the American perspective, when you have heaps of money, you don't think. You solve the problem by throwing money at it. And I think Australian startups and founders are way stronger because they're forced to think. We're all forced to think because there is no money. We've got to be incredibly frugal with where we do spend, incredibly scrappy in how we get things done, really, really focused, and only do the right thing, and spend a lot of time thinking about what the right thing is, getting that strategy right. Whereas, if I had $10 million to go after this startup, which is probably what I would have asked for had I been starting in America, I think I would have squandered some of it. So just the fact that I've been forced to wallow around without financing for quite a while, I think that's going to make me and my company a lot stronger in the long run.
Yeah, no, that's interesting. Like we definitely don't have sort of that risk appetite or I guess availability of capital, but as you said, yeah, that constraint could also be a benefit because then we're not, just throwing around all this money unnecessarily, and we're actually having to, work within those bounds to develop something. So, no, it's an
Well,
interesting,
it
yeah,
it stifles innovation on the other hand, because for people like me who are incredibly driven and kind of obsessed with rockets, um, I am who I am. But there's 100 other people who could have had a bright idea that could have, solve some of the problems of today. And they're basically forced into their day job because they got to pay off their $1 million house that just got flooded last year. So I think the lack of funding hurts the innovation and it hurts the innovative competitiveness of the country. So, like, there's good and there's bads.
yeah, absolutely. So something I'm personally very interested in, this is, looking to our research sector, universities and research organizations to see how we can, really accelerate innovation by commercializing the technology and the IP that they already have and are working on. We're spending billions of dollars on, but a lot of it never sees the light of day in terms of getting to market. So do you think this is an issue that needs to be solved? Should we be looking to, commercialize IP from universities? Or are we better off just starting from scratch and building our own?
Mate, so iLaunch is and the Trailblazers, it's hearing what you just said from 1,000 voices across the country. Everybody's saying it's so hard to get that IP out of the universities. And I'm at the front lines fighting for the innovator in you to basically form this new way of doing business. I'm not saying I'm going to do it all right, but I hope that in the iLaunch program we have some success where, like I said, industry had some secret sauce that was missing from their product. Uh, the government money behind iLaunch helped them bring in the universities, and the IP arrangements are very different from previous funding organizations such as CRCs. So that's something that is very attractive to industry. And then focusing on later stage innovation instead of early, lower TRL. That's another way of thinking about it. So, iLaunch is TRL focused. By the time you get to TRL 7, you almost have a product. Like it is more than 90% there. There's just like there's things that need to be done, and they tend to be expensive things when you talk about space hardware, like flying into space.
Yeah.
But realistically, I think, I'm trying to be a part of the solution here, trying to make Australia a better place. And I do think the universities have amazing capabilities. They certainly have the facilities and the hardware, and they definitely have the heads. But I think they just need to be enabled to work with the industry in the right way. Um, Programs like iLaunch and the University Trailblazers programs are a great start. I really hope to do well with iLaunch, and I hope that a lot of our products transition and eventually fly in space and become space products, because that'll be like uh, consideration for the government to think about a next program, the Trailblazer 2, iLaunch 2, and then hopefully learn. And then that's another thing. You learn by making mistakes. So iLaunch is a 4-year program. We're going to make some mistakes. That's okay. We can learn from that, hook that into the next grant program, and then do it better. Maybe 3 years is the sweet spot. I don't know. But
Yeah. No, I agree with you. I think a lot of it also comes down to sort of like incentives and getting incentives aligned with academia and industry and startups, and actually, yeah, just building that sort of like collaboration to actually be able to do things.
Well, grant money is always a great incentive to get stuff done. Look, industry, if they don't have a product yet or if their product line is weak, they're going to be lacking money. And I'll tell you my opinion, having spent a lot of time in the industry. Uh, how do you grow an industry? You help the industry have products so they can sell them, so they have revenue to design next products. But if they never get that first product, then where's the revenue going to come from? So you have to have this
Yeah.
pipeline from early stage innovation, later stage innovation, product, money, and then go back and reinvest.
Yeah, no, that makes a lot of sense. So, what are some of the main differences you would say are between sort of the US and your experience there and Australia when it comes to building new capability and products?
Australia is small, and that means a lot of things. And I mean small by people. So everybody knows everybody, and that's a good thing. I really like that. It's really straightforward to find the right person, um, but sometimes it's one person. Uh, so whereas in the US, it might be harder to find the right person to help you, but that's because there's 10 people and they're differentiated in how they can help you. So that's a major difference is the economy of scale. And it means the competitiveness is different. So America feels substantially more competitive because there's 10 people doing exactly the same thing you're doing. So you've got to do it better to stand out. You've got to do it different to stand out. In Australia, it's small enough that like there could be one player doing an activity, and that's good enough. That serves the needs. Another thing is, due to the scale, the levels of financial investment at every level are different. So iLaunch is a very big program for America, $180 million. Um, and if you looked at like larger states like California, their grant programs are $500 million. Okay. And then the national programs are, $30 billion. So when you talk about economies of scale, our scale is just smaller. You're going to get less done with less money. But like I say, Australians are scrappy. I'd say we get twice as much done with the dollar as an American might because since they have more money and it's easier to come by, they might waste it. Whereas we've got to treat it like a very precious resource. Um, and then another thing is like the nature of the country is we're all localized in just a few cities by and large, whereas America's really spread out. Um, and that has a lot of implications in terms of, when you go to a conference, like that's when you meet everybody in America. But when you travel around Australia, when you're in any of the cap cities, you can literally do one-stop shopping on all your colleagues. So you don't have to wait for one of those conferences to come around because in America there's many cities, so many universities, so many locations. You could go to one city and that's just one company, as opposed to you could go to Sydney and talk to half the ecosystem.
Yeah, yeah. No, that's some interesting insights. A lot of good points. I want to ask, do you have any advice for any wannabe engineers or people who are maybe already studying engineering? Like, what fields should they get into? Should they do mechanical, electrical, aerospace, mechatronics? There's so many options now. Like, what are the good fields to get into, do you think? I guess now and looking to the future and what's happening.
So look, I'm really bullish on quantum. I think it's got a huge future. Um, the cyber field is going to be huge in security. AI is massive, but ignoring where I think technology is going, because I could be wrong or I could be right, it doesn't matter. The most important thing is that you love what you're doing and you're playing with toys, you're having fun. If you love and you're passionate about your work, then it's play. And then, you're not just counting the days sitting at a desk. You're not just doing it for a paycheck. And so my actual advice is as early as possible, expose yourself to the different fields. So, you think you might want to be a software person? Well, start playing with software now, okay? And if you say, gosh, I hate this, stay away from it. If you want to be a mechanical design, if you really enjoy mechanisms, if you enjoy putting things together, have a crack at it as early as you can. You know what I mean? Get involved with your uni, get involved in your high school. Try and build something and design something. And if you find that you don't like it, go to software. If you don't like playing with data, stay away from it. If you don't like something, don't do it. But the sooner you figure out what you don't like, the sooner you can figure out what's going to make you happy. And then once you figure out what makes you happy, chase it, excel, do the best you can. And if you're passionate about it, you're going to do great.
Yeah, no, I love that. That's great advice. Can you still hear me, by the way? I've just frozen.
Yep.
Okay, just a sec. That's right, I'll edit this out. I don't know why it's doing this. Ah. Troubleshooting.
I can see you. We can just continue.
Yeah, but I can't pause it or anything. Ah, can you still hear me?
Yeah, it's still fine.
That's so weird.
Let's just carry on.
Alright. Alright, we'll carry on. I'll fix it after. Okay. So, what about, you're studying engineering, you get your degree. What should you go into? Do you think industry, big company, a startup, or maybe getting into research? Do you have any advice around that?
It's the same answer. What do you love to do, right? Do you love to tinker, but maybe not want to be held accountable because you're the kind of person who's a bit more creative? Like that's a research type. Um, you know, if you can come up with a great discovery, then it's valuable. It doesn't hurt that you're in academia. And as a matter of fact, there's a certain kind of attitude that researchers have. If you just want to get stuff done and build it, go into industry. It'll be great. And if you're really a turner and a burner and you don't mind putting in the extra hours, you're going to learn heaps in a startup. Whereas a more larger developed company is going to offer a more work-life balance. So if you got kids and a family, maybe that is better. Or if like you really need to dial it back a bit, like government is acceptable. You're going to get paid more in big industry, um, but it is going to be slower than a startup where you might get paid less, but the upside is stock and the potential bonus that could get you. Um, in government, you'll get paid less, but life is a bit easier, and you might not learn as much and it might not grow as fast, but if you need to really take care of your kids and your family, like it offers you a lot more flexibility. And research is kind of like choose your own adventure. If you want to turn and burn real hard, some researchers build amazing research groups. Um, if you want to focus on your pet project because you really believe in it and you can see the future, you can do that. And good research actually ends in a spin out and turning into a startup. So um, there's nothing wrong with that. And then the last thing is do it. If you've done it for 2 years and all you wear is a frowny face, then you need to leave. Don't let it last 5 years or 10 years. You need to move on because life's too short to wear a frowny face all the time.
Yeah, I love that. I love that. I think, yeah, especially like maybe at the start of your career, I think optimizing for learning and skills is probably like the good way to go as opposed to, a comfy corporate or government position. I think it's a potentially good way to think about it as well.
But that's you. I guess you don't have kids, you don't have a family to take care of, so
Yeah,
everybody's
yeah.
got their own circumstances, and you got to make a choice that is right for the circumstance.
Yeah, no, absolutely, absolutely. Okay, so just as sort of a closing question, I love to ask this one. What is your vision of the future and how do you hope to build that future?
So my vision of the future is the science fiction that I've been watching and reading since I was 5 years old. Spaceships, space cities. Uh, we live forever. You can cure pretty much every bad thing, ailment. Um, Communications easy. No real things that are missing from our lives. Like I'm not going to starve. Nobody's starving. I'm a big fan of Star Trek, which is the utopian science fiction future. Um, and I would prefer to imagine the future is utopian. Not the Terminator future, not the Star Wars future. Um, and like, I think I'm helping to build that. I worked on drones, and now look at drones, little flying robots in the sky. Everybody's got one. They cost a couple $100. Every kid's got them, and they're cool. They take pictures and do things. So like, and I don't know what I'm going to be a part of inventing next, but I know it's going to be something directly out of sci-fi from some author somewhere.
Yeah, that's amazing. An incredible vision. And you know what? I think you will achieve all of that. And you are playing a big part in it already, which is awesome. So, where can our listeners go if they want to find out more about you or chat to you or even potentially, look at partnering with iLaunch?
LinkedIn is my business card. I think as long as that platform is the best market share, find me on LinkedIn.
Amazing. Well, that's it for today. But Joni, that was amazing. I really appreciate you coming on and having a chat with me. And yeah, it was a great episode and great to learn more about you.
Thanks.
Thank you. See you later.